example, we can see a odd shape, and it can be difficult to think about how we would find the area for this composite shape. But if you take a second to look at it, you'll see it's actually composed of a couple of simple shapes, but instead of being added together like we did before, they are taken away from a larger object. This shape is actually composed of two small circles and one large circle, with the two small circles being taken away from or minus from the original large circle. Now, given some dimensions, we can have a look at how we would solve for the area of the original composite shape.
Given the information that we have just learned, we can see that this composite shape is a circle minus two smaller circles. Now, using the dimensions that we've been given, we can solve for the area of the composite shape. The first thing we're going to do is solve for the area of the large circle, then solve for the area of the two small circles, finally taking those small circles' area away from the area of the large circle. So, let's do the first circle. What do we know about the first circle? Well, we know that its diameter is equal to 20 meters. We also know that the radius is equal to the diameter divided by 2. So if we to work out the radius, we do 20 divided by 2, which is equal to 10. So the area of this circle is given by the equation area is equal to pi r squared. Well, we know what our radius is, so we can just solve for this area. It's going to be equal to pi times 10 squared, and that is going to be equal to 314.16 meters squared. So our area of our large circle is solved for. Now we just need to solve for the area of our two smaller circles. So let's look at the area of the first small circle, which was this red one here, which we'll call A1. Is equal to, well, what have we got? We've got the diameter again is equal to 8 meters, which means the radius is equal to 4 meters. So this is going to be equal to pi times 4 squared, which is equal to 50.27 meters squared. And if we look at the dimensions for the second circle, we can see that they're exactly the same. So these are two identical circles, which means we can call our second circle, this grey one, A2, and that will have the same area, 50.27 meters squared. So, in order to solve for the total area of the original composite shape, we take our large circle's area, which was equal to, so total area is going to be equal to 314.16 minus this first circle of 50.27 minus the second circle of 50.27, and that works out to be 213.63 meters squared.
In this next example, we can see another odd shape and another difficult situation to think about how we might conceptualize calculating the area. But this again is made from only three individual simple shapes. One of them is a semicircle and the other two are two small triangles. So like the other one, these two small triangles have been taken away from the area of the large semicircle. And in order to solve for the area of the original composite shape, we need to determine the area of each of these three objects and then take away the area of the two small triangles from the large semicircle. Now let's get some dimensions and let's look at some formulas and see if we can solve for the area of the original composite shape.
In this composite shape, we can see that it is a semicircle. Take away two triangles. Now, in order to solve for this area, we need to remember the area of a semicircle. The area of a semicircle is given by the equation 1/2 times the area of a circle, which is equal to 1 over 2 times pi r squared. Now, in order to solve for this, we need to find the radius. We don't have the radius. We have the diameter again. And the diameter is equal to 40 meters. So the radius, we know, is equal to half of this, is going to be equal to 20 meters. So in order to solve for the area of the semicircle, it's going to be A is equal to 1 over 2 times pi times 20 squared. And this is equal to 628.32 meters squared. Great, so we have the area of our original shape, the semicircle, and now we need to take away the two areas of triangles. And the area of a triangle, if we remember, is given by the formula. Angle is given by the formula half times base times perpendicular height. Now in this case, both the dimensions of the base and the perpendicular height are the same. They are both 6 meters. So this is going to be, so this first triangle's area, which we'll call A1, is going to be half times 6 times 6, which is equal to 18 meters squared. And if we look at the second triangle, this green one here, we can see that it has the same dimensions. So A2 is going to be equal to 18 meters squared as well. Now that's all that's left is for us to take away the area of the two triangles from the large semicircle. So the total area of our original composite shape is going to be equal to 628.32 minus the initial 18 from the first triangle minus the other 18 meters from the second triangle. And that works out to be 592.32 meters squared.
This example looks a bit like a set of eyeballs or a set of binoculars facing straight ahead, but it is actually composed of a rectangle and two small circles, where the two small circles have been taken away from the large rectangle. So in order to solve for the area of the original composite shape, we solve for the area of the rectangle, and then we solve for the area of the two circles and minus them from the area of the large rectangle. So let's get some dimensions and let's get some formulas and see if we can solve for the area of this composite shape.
To find the area of this composite shape, we can see it's a rectangle minus two small circles. So let's first find out the area of a rectangle. Well, the area of a rectangle is given by the formula length times breadth, which in this case is equal to 25 times 8, which is equal to 200 meters squared. Now that we have the area of our large rectangle, we just need to work out the area of our two smaller circles and minus them from the large rectangle. So we'll call our first circle, this yellow one, A1, and A1 is going to be equal to pi r squared, but we don't have the radius. What we do have is the diameter, and in this case the diameter is going to be equal to 8 meters, which means the radius is equal to 4 meters, because we know that the diameter is 2 times the radius. Therefore, the radius is equal to the diameter divided by 2. So now we can solve for A1. Well, A1 is going to be equal to pi times 4 squared, which is equal to 50.27 meters squared. Now let's solve for the other small circle. But we can see the other small circle has the exact same dimensions as the original circle, so we can say that it is also equal to 50.27 meters squared. So now that we have both of our circles solved for and our large rectangle solved for, we can find the total area of our composite shape. The total area is going to be equal to our original shape, the rectangle, which is 200 meters squared, minus 50.27 for the first circle, minus another 50.27 for the second circle, which is equal to 99.46 meters squared. Again, just make sure you identify the shapes correctly and make sure that you are taking the end results away.
Thank you for watching this video. I hope it was helpful, and I hope it helps you realize that not all composite shapes are formed by addition, some are formed by subtraction, and we can make very complicated shapes when we combine both together. But knowing how to calculate the area for both types of questions is very important. So I hope this helped, and I'll see you in the next video.